Hey guys, welcome to ANS Solver. Today we'll be doing the concept of the Poisson distribution as an approximation to the binomial distribution, which is basically how to convert from the binomial distribution to the Poisson distribution. This is a subtopic in the chapter of Poisson distribution. Okay, it's a very important concept to know. Okay, because many past paper questions are asked on this. Okay, so yeah, if you understand this concept properly, you will be able to solve many past paper examples and questions, correct? So let's start with what is binomial distribution. This is basically revision from AS level. We know in binomial distribution, okay, the mean is n p, correct? N multiplied by p. N is the number, p is the probability of success. The variance is given by npq, correct? N is again the number, p is the probability of success, and q is basically the probability of failure, which can also be written as 1 minus p, correct? And now the standard deviation is always the square root of the variance. So I have the square root and I know my variance is npq, correct? So this is what I basically have. Correct, this revision basically from AS level, it's very important, okay, for you to know your AS level concepts also, correct? So now, how do I convert from binomial distribution to Poisson distribution? You always convert from binomial to Poisson, not the other way around. Okay, this is what you basically need to know. So basically, there are some conditions, okay, which you need to satisfy to do this. Okay, the first condition is that your n has to be large. Okay, your n has to be large. Basically, your n, to give a numerical value to it, okay, your n should be more than 50. Okay, this is very important to remember. Your n should be more than 50. This is the first condition. Now the second condition is that p should be, okay, p should be small enough, okay, small enough to ensure, okay, it should be small enough to ensure that np, this is the second condition, okay, the numerical value, np should be less than 5. Okay, so basically the two important conditions are n should be more than 50 and np should be less than 5. This obviously n and p will be given to you as the question will first be in binomial distribution. Then you will have to convert it to Poisson distribution. Correct? So basically if these two conditions are satisfied, okay, then what you can do is you can convert, okay, from binomial. Binomial is written as n comma p, correct? This is the distribution of binomial. This can basically be then converted to Poisson, correct? Which will look basically something like this. Now you need to know that your lambda here is basically equal to np, correct? Because lambda is the mean, correct? And basically you need to know that after conversion, your lambda value will basically be n into p, correct? Easy to understand. And as lambda is both mean and variance, so basically you've got both your mean, variance, and hence the standard deviation also, correct? So these are basically the most important conditions. And yeah, you obviously need to know that binomial distribution and Poisson distribution are both discrete variables, okay, hence there will be no continuity correction. Okay, we'll again go through the concept of continuity correction actually in the next video, okay, because there we are doing basically we are converting from Poisson distribution to normal. So that's actually in the next video. But before that, what we'll do is we'll do some past paper practice, okay, of approximating, correct, of approximating the Poisson distribution to binomial distribution, correct? So basically this is from 9709-2020 Feb March paper 62, okay? So the booklets produced by a certain publisher contain on average 1, incorrect letter per 30,000 letters. So as you can see, this is basically the probability you have. This is basically your P. Correct? You always need to identify. And these errors occur randomly. A randomly chosen booklet from this publisher contains 12,500 letters. So I need to use a suitable approximating distribution to find the probability that the book contains at least 2 errors. Before that, I need to use an approximating distribution. I know this thing here is my n. Correct? So now, can this be converted to Poisson or no? See, basically it needs to match the conditions. First you have your n, which is more than 50. Correct? In this case your n is 12,500, which is more than 50. Correct? So this condition is satisfied. The second condition is your NP should be less than 5. Okay? So your n in this case is 12,500 multiplied by the probability you have is 1 over 30,000. Correct? Because 1 in 30,000 letters. Correct? So when you do 12,500 multiplied by 1 over 30,000, you basically get your answer basically as, you can write this as 5 over 12, which is basically 0.4166. And as you know, 0.4166 is less than 5. That means even this condition is satisfied. That means I can convert, okay, from the binomial, which was 12,500, comma 1 over 30,000. Correct? I can basically convert this, okay, to Poisson. Correct? The Poisson, you know your lambda, okay, your lambda is always n into p. So in this case, we've already calculated our n into p, which is basically 5 over 12 or 0.4166. So I can simply just write this as 5 over 12 to be accurate. Correct? You know, you can even write it as 0.4166, it's the same thing. So now I have my lambda here. Correct? Now I need to find the probability that this booklet contains at least 2 errors. Okay, so basically what I need is, I need the probability, okay, that the book has at least, the sign for at least is basically more than equal to. So I simply write more than equal to 2. Correct? This is what I basically get. The probability of x should be more than equal to 2. So whenever we have more than equal to, we write this as 1 minus the probability of x being less than equal to 1. Correct? So this can basically be written as 1 minus the probability of x equals to 0 plus I can write the probability of x equals to 1. Correct? So now this can basically be written as 1 minus, I know the formula is e raised to minus lambda, correct, multiplied by lambda raised to x over x factorial. So I can write this as e raised to minus 5 over 12 plus 5 over 12 multiplied by e raised to minus 5 over 12. Correct? This is what I can simply write. So now you can either use the calci method. I'll explain it to you so that it's easy. You can click on shift. When you click on shift, you can click on the log button. Okay, solve this. Okay, I'll just write this. This is basically on the calci. Correct? So when you do that, you basically get a summation sign with a limit here, correct, and a bracket here. First, we'll calculate the summation inside the bracket, which is basically from 0 to 1. Correct? So I write 0 here, I write 1 here, and here I write e raised to minus. I know my lambda is basically 5 over 12 multiplied by, here I can write 5 over 12 raised to x divided by x factorial. X will take all the values from 0 to 1, and to write an x, you simply click on alpha and the closing bracket sign. Correct? So basically you do e raised to minus 5 over 12, correct, multiplied by 5 over 12 raised to, you can do x divided by x factorial with the limits 0 to 1, correct? That's what you do on the calci. After that, when you click on equal to, you get your answer 0.9339. But this is basically the value in the blue underlined portion. You need to do 1 minus 0.9339 to get your answer, correct? So when you do that, you get your answer basically as 0.0661, correct, which is basically the final answer of the question, correct? This is what I basically need, and this is the final answer. So the main thing you need to understand is whenever they give you, binomial, see if it matches the conditions, correct? Once it matches the conditions, you can simply convert it to Poisson and then do the normal Poisson distribution, okay, which we know how to solve. Now let's do another example so that we are 100% sure with this concept. So this was basically tested in 2020, October-November paper 62. So on average, 1 in 50,000 people, which is again, this is the probability, have a certain gene. Use a suitable approximating distribution to find the probability that more than 2 people in a random sample, okay, of 1,50,000 have the gene. So I know this is my n. So first, see if it matches the condition. I need my n to be more than 50. My n in this case is 1,50,000, which is more than 50, obviously. Now I have my NP, which is less than 5. Okay, so this is basically 1,50,000 multiplied by the probability, which is 1 over 50,000. Correct? So when I do this, I simply, solve this on the calci. Correct? So I get my answer basically as 3. And as you know, 3 is less than 5. So both the conditions have been satisfied. That means I can convert, okay, this from the binomial, which was n comma p, which is 1,50,000, comma 1 over 50,000. Okay, this can be converted to the Poisson, okay, the Poisson with, I know my lambda is n into p, correct? In this case, we know my n into p is 3. So I have my lambda as 3. Now, what do I need? I need to find the probability that more than 2 people in a random sample. Okay, so I need the probability of x being more than 2, which can be calculated as 1 minus, because I need more than 2, that means I need from 3 to infinity. So I do 1 minus the probability of x being less than equal to 2. Correct? So I can basically write this as 1 minus the probability of x being equal to 0 plus the probability of x equals to 1 plus the probability of x equals to 2. Correct? This is what I can basically write it as. So now what I can simply do is, I know my formula is e raised to minus lambda into lambda raised to x divided by x factorial. So I can basically write this as 1 minus e raised to minus 3 plus 3 e raised to minus 3 plus e raised to minus 3 into 3 raised to 2 over 2 factorial. Correct? So now I can again use the calci method, which we've mentioned. So shift log, then you basically get the summation sign here. Correct? Now what you can simply do is you're calculating the summation from 0 to 2. So I write 0 here, 2 here, because we solve the bracket first always. Here I write e raised to minus 3 into 3 raised to x over x factorial. To write an x, I simply click on alpha and the closing bracket sign. Correct? So to repeat myself, okay, You click on shift log, then you write e raised to minus 3 multiplied by 3 raised to x over x factorial between the limits 0 to 2, correct? And after that, when you click on equal to, you get your answer basically as 0.423, correct? Now what you basically do is you write 1 minus the value, correct? That's what we need to do. So now when I solve this on the calci, I get my answer basically as 0.577 basically as my final answer, correct? So this was basically the concept, okay, of the approximation, converting basically from binomial to Poisson. Okay, so the most important thing is, understanding the conditions here. These two conditions always have to be satisfied, correct? So yeah, now we'll do the conversion from Poisson distribution to normal distribution, which is a very important concept in the next video. Okay, we'll do that. Okay, I hope you enjoyed this video. See you in the next video. Thank you very much.